Can you hear me? Anyone?
Yes, sir.
Okay. So already two lecture link, mainly video link of previous two lectures. Discussion class basically is are given in PUX private, sorry, in Slack private channel. Okay, and basically two lecture was about vectors. Okay, so tomorrow at 9 p.m. Sorry, not 9 p.m. 7 p.m. There is a quiz, which is credit quiz.
স্যার
Yes.
স্যার আমাদের কুইজ গুলোর জন্য কি স্যার টেক্সট বুক গুলা পড়তে হবে নাকি ভিডিও গুলা দেখলেই জাস্ট হবে?
I think you can practice some conceptual question from your textbook, but content mainly used in video lectures are enough, I think. Okay, but for your
ওকে স্যার।
practice, you can just practice some conceptual type questions. So maybe checkpoint. There was checkpoint, name checkpoint. Okay, in textbook. Okay. Okay, so the just question pattern is MCQ type question. Okay, similar to that pop quiz, but you will get one chance to attempt one question, and there will be 5 MCQ questions. Okay, you will get 45 minutes to answer the 5 questions. Okay, and mainly formation is basically Google form. Okay, okay. For example, similar questions is like that. If the dot product A dot B uh, of two vector is equal to 1, then what will be the angle between these two vector A and B? Okay, so we know that basically dot product of two vector depends on the angle between two vector. So cos 0 degrees 1, and mainly sine 0 degree is 0. Okay, so that's why mainly in case of dot product, say for maximum result, if you get maximum result, then theta will be 0 degree. Okay, and if the result is minimum, then mainly theta will be 90 degree, because cos 90 degree is 0. Okay, so this type of question basically, so option will be like that: 0 degree, 90 degree, 180 degree, or infinity. Okay, so next topics is about motion of an object. Week 2 lecture 1 basically about motion of an object. So basically position, displacement, and velocity and acceleration. Okay, so let's talk about the position of an vector. So position of an object, so how can we find out the position of an object? Okay, so position of an object. So if we try to describe the motion of an object, then we have to need a clear concept about the position of an object, because the change in position produce the motion of an object. Okay, so if we consider a object, this is the object. Okay, so now we have to introduce a point which is considered as the origin to find out the position of that object. Okay, so if I say it like that, the object is 10 meter away. So the question is 10 meter away from what point or what reference point. Okay, so we have to introduce a point which is called the origin, or we have to introduce coordinate system. So basically, if we consider x and y coordinate system, so this is the origin, and at the origin, the position of an object is considered 0. Then from that origin, we can say this is 10 meter away from that origin along the direction of x. So this object is in x plane. Okay, in x axis basically. So in one dimensional case, here we are going to discuss one dimensional motion. Okay, in one dimensional case, we only consider the x axis. Okay, now the thing is that the position of an object is a function of x, and this x is changing with respect to time, because at a certain time, say we consider initially at time t equal to 0 second, we consider the t equal to 0 second, position object of that object is 10 meter. Now if we consider at a certain time t equal to 3 seconds. This is the position of that object x3, and at a certain time t equal to 5 seconds, the position of that object here, which is x5. And from this we can say that the position of an object is changing with respect to time. Then we can introduce a function x, which is basically depends on t. So xt is equal to say 3t square minus 2t plus 10. So we consider this is the equation which is describing the motion of an object or the position of an object. Okay, so if the equation of motion or equation of position of an object is given, then we can easily find out the position of an object at a certain time. So if the question is given like that, find the position of that object, find the position of the object at equal to say 3 seconds. So what will be the position of that object at t equal to 3 seconds? Now if we put the value of t of that equation, it will be x3 is equal to 3 into 3 square minus 2 into 3 plus 10. It's equal to 27 minus 6. This is 21 plus 10 is 31. Okay, so 31 is the position of that object at t equal to 3 seconds, and the unit of the position is meter. Okay, you can also write down the centimeter. If the equation is given in centimeter, then unit will be centimeter, and if meter, then unit will be meter. Okay, so in SI unit, basically the unit of the position is meter. Okay? So this is the first topics, and another main thing is that here, if we try to find out the position of an object, just we have to introduce a reference point or particularly a reference frame, so that we can easily find out the position of an object. So without this type of reference point or reference frame, we cannot describe the position of an object and also the motion of an object. Okay, so this is one dimensional case. So if the question is given in 2-dimensional, then there will be also additional part, which is basically y. Okay, so y, say yx, say xt equal to this type of an equation, and there will be another equation y equal to say like minus t square plus 2t plus 1. Okay, so like that. Okay, so this is the main procedure. How can we find out the position of an object? And another thing is that the position of an object is also a vector quantity. So if we consider 1-dimensional case, so there is a vector, unit vector, which is I. Which is I. So in 1-dimensional case, we basically try to ignore the vector quantity. So that's why we are using here scalar things. 31 is a scalar number, so that's why 31 meter. But if you try to give the vector sign, then you have to introduce a unit vector I here. Okay, so this is the procedure for vector. Now, second part, second topics is basically displacement. Displacement. So displacement is the change in position. Displacement is the change in position. Change in position at a certain time. Okay, change in position at a certain time, and then we can write down the displacement equation like that. Del x is equal to x final minus x initial. Okay, so final position minus initial position gives the displacement. So xf is the position at tf time, and xi is the position at ti time. Okay, now if the question is given like that, b number question b, find out the displacement del x equal to what, between time interval t equal to 2 seconds to t equal to 3 seconds. Okay, so first we have to find out x2. So now if we put the value of 2 here, it will be 3 into 2 square minus 2 into 2 plus 10. This is 12 minus 4, 8, so 18. Okay, okay, so 18 meter, and x3 is equal to 31 meter. Okay, so you can use also unit vector. If you give here I, there also I here, so I'm just using the scalar quantity here. Okay, okay, then we say del x, here del x is equal to x3 final position minus initial position, then this is equal to 31 minus 18, 31 minus 18, this is 13 meter. So the unit of the displacement is also meter. So 13 meter is the displacement of that object between time t equal to 2 seconds to t equal to 1 second. So this is the procedure to find out the displacement. And next topics is velocity. Okay, so the velocity is basically vector quantity, and the magnitude of this velocity is called the speed. Okay, so velocity, and the definition of the velocity is basically change in position with respect to time. So we can say change in position, divided by time interval, and then this is equal to del x by del t. So if we divide displacement with respect to time, it gives the velocity, and basically this is called the average velocity. So velocity is two types. One is average velocity and another is, so velocity is two types, one is average, another is instantaneous. So someone tell me what is the difference between this instantaneous velocity and average velocity, or what does mean average, or basically average and instantaneous.
The second one, if we take the total displacement by total time of the whole journey, and
Yeah.
instantaneous velocity is the velocity at any single point in time, like at
Yes.
any time. That's the instantaneous velocity, and average one is the total displacement by total time, like the average of the displacement at all the times.
Okay, so basically average velocity, in case of average velocity, the time interval is large, more than 1 second or 1 second. Okay, so large time interval will be large, but in case of instance velocity, time interval is very close to 0. So basically at a certain time, say there will be a single time, the velocity, if we calculate the velocity at a single time, then it's called the instantaneous velocity. So the velocity at 10 second, or velocity at 12 second, 13 second, 1 second, 2 seconds, so these are the instantaneous velocity. But in case of average velocity, we have to consider there is a time interval which is very large. So either it's from starting point to end point, or from middle point to at a certain time. Okay, so this is the difference between average and instantaneous velocity, and the formula for average velocity is del x by del t, and in case of instantaneous velocity, we can write down like that. So if we give the modulus sign, so not modulus sign, if we give the limit, so v equal to, there is a limit in case of instantaneous velocity, so limit del t tends to 0, and del x by del t. Okay, So in mathematics, I think you are familiar with this type of equation. In mathematics, is there is a limit here del x or del t tends to 0, then del x by del t will be converted into dx by dt, which is basically the differentiation, first order differentiation of position. So if we differentiate position, then we'll get the velocity, which is called instantaneous velocity. So this is the basic difference between average velocity and instantaneous velocity. In case of average velocity, no need to differentiate the position, just find out the displacement and then just divide this with time interval. So this is the average velocity, and in case of instantaneous velocity, just we have to differentiate the position and then just put the value of t. So say the question is given, find out b average equal to what between time interval t equal to 2 seconds to t equal to 3 seconds. Okay, t equal to 3 seconds. And another question is like that, find out the velocity equal to what at t equal to 5 seconds. Okay, so here there is a difference between these two. There is a time interval or 2 time given here. We have to find out the velocity, which is average velocity between t equal to 2 seconds to t equal to 3 seconds. And in case of instantaneous velocity, there is a single time. So instantly at 5 seconds, we have to find out the velocity at 5 seconds. Okay, so in first case, average velocity is equal to x3 minus x2 divided by 3 minus 2. So here x3 minus x2 was 18, not 18. I forgot what was the result. X3 20, it was 31. So 31 minus, in case of 2, 18 divided by 1, and it's 13. Okay, so 13 meter per second, and the unit of the velocity is meter per second. So unit of the velocity is meter per second. So 30 meter per second is the average velocity between time t equal to 2 seconds to t equal to 3 seconds. And in case of instantaneous velocity, we have to differentiate x with respect to time t, and you have to memorize a formula which is basically dx of x to the power n is equal to n x to the power n minus 1. So this is the differentiation of x to the power n. Now if there is a constant here, say there is a constant given here, just this constant will remain same, multiplied by this n x to the power n minus 1. And if there is a constant, only single constant, so differentiation of single constant ddx of c is equal to 0. So differentiation of constant is 0. But in case of addition or mainly subtraction of equation, then it will you can divide separately. Just you can differentiate separately. Okay, so here d dt x is given 3t square minus 2t plus 10. Then here 3 remains same, 2t, because 2 minus 1 is 1, minus 2 into 1, and the differentiation of constant is 0. So then it will be 60 minus 2. So 60 minus 2 is the first order differentiation of position. Now if you put the value of 5, then v5, basically velocity at 5 seconds, is equal to 6 into 5 minus 2, which is 28. Okay, so 28 meter per second is the instantaneous velocity, and 13 meter per second is the average velocity at that case. Okay, so this is the procedure to any question.
Sir, one question.
Yes.
Let's say that the equation for displacement is 2x plus 3. So now if we differentiate it, we don't have any x in the equation. In that
Yes.
case, what should we do?
Uh, if there is the answer is constant, if answer is constant, then the value is constant throughout the same throughout the motion. So in that case, average thing and also instance thing will be same.
Okay.
Okay, so if there is no dependent variable here t, say the answer is 6. Okay, here say the answer is 6. So here first order differentiation of position gives constant value. Okay, so that in this and that in that case, no need to find out, just no need to there is no way to put the value of time. So how can we put the value? So basically the thing is that here in that case velocity is constant throughout the motion. So this
Oh
velocity
yeah,
is
that's
6.
the modulus. If I say that 3x plus 2, and if I take it as the equation in the graph, that 2x is the modulus mx plus c. So the modulus is the velocity. So in
Yes,
this
yes.
case, it's
Oh,
the
okay, okay,
velocity
okay.
is constant.
Okay,
Yes, I
so
got it.
in case of a straight line, so
Yeah.
just dx by dt. So
It's dx by dt is constant.
yes, so if dx by dt is constant, then velocity is constant through the all of the motion. So at that case, no need to just calculate the instantaneous velocity. If you want just calculate one time the velocity, either average or instantaneous velocity, then its velocity is always remains same. Yeah. Oh, is it clear to you, or what was the question?
Oh, no, it's clear. My question was that if we have an equation for displacement like 2x plus 3, in this case the power of x is 1. So if we
Yes, yes,
differentiate it, then
yes, yes,
the x will be gone.
yes,
So
yes.
later I got my answer
Not
that it
yes,
will
yes,
be constant as
yes,
if
yes,
as it's a straight line. So the
yes,
velocity would be constant at every interval of time.
yes, yes. If the value, I mean, if first order differentiation is constant, then it will be constant throughout the total motion basically. So velocity is constant. If basically if the equation is given in first order case, then the velocity is constant. So here the equation is in second order t square. So that's why there is a particular difference between average velocity and instantaneous velocity. Okay. So next question is about or next topic is about acceleration. So in case of acceleration is similar to the velocity. Only difference is in case of velocity, the formula was displacement divided by time. In case of acceleration, we can say change in velocity with respect to time. So this gives basically average acceleration. This is average acceleration. This is average acceleration, and another acceleration is instantaneous acceleration, which is basically the second order differentiation of position, d square x by dt square, or we can say first order differentiation of velocity, dv by dt. Okay, so similar, similar procedure. The question is given like that: find out the average acceleration between time interval t equal to 2 seconds to t equal to say 4 seconds. Okay, t equal to 2 seconds to 4 seconds. So and in that case you have to find out the instantaneous velocity at 2 seconds and instantaneous velocity at 4 seconds, because the formula is for average velocity, average acceleration is v4 minus v2 divided by 4 minus 2. So here v4 and v2 are the main instantaneous velocity. So this is the velocity at 4 seconds and this is the velocity at 2 seconds. So v was like that, 60 minus 2. Now if we put the value of t here, then for 4, 22 minus for 2, 10 divided by 2. So it's uh, 6 meter per second square, and the unit of the acceleration is meter per second square. And in case of instantaneous velocity, we can say if we differentiate this, a equal to d by dt is equal to 6. So this 6 is constant. Okay, so here 6 is constant. So we can say and this velocity instance acceleration and average acceleration are same. Okay, so you can say that this in this motion, this type of equation, for that equation, acceleration is constant basically throughout the total motion. Okay, so we can say instantaneous acceleration at t equal to 2 second, t equal to 4 second, t equal to 10 second, or t equal to 100 second is same, which is 6. Okay, so these are the procedure to calculate the position, velocity, and acceleration in one-dimensional case. Okay, and another thing is that if the acceleration is given like that, 3t minus 2, how can we find out the velocity and position from that equation?
Integration.
Sorry.
Integration.
Okay. The thing is that we have to integrate that part, because first order integration of the acceleration with respect to time give the velocity, and if we integrate further velocity with respect to time, it gives the position. Okay, so reverse process is also possible here. So if the question is given like that, then you have to just integrate that part. And in case of integration, there is a formula. If we consider say x to the power n dx, x to the power n dx, the formula is basically x to the power n plus 1 divided by n plus 1. Okay. Okay.
So one
Yes.
question.
Yes.
Suppose we are given like there's a 3t minus 2 is the formula, I mean the equation for acceleration. So
Yes.
when we will integrate it, it would be 3t square by 2 minus 2t plus c,
Then
right?
the const.
So
Yes.
yeah, to find the c, we would be given hints in the question like
Yes.
at
Yes.
t equals to 0, it was in
Yes.
rest. So if it's in rest, then the velocity is 0. So like
Yes.
that hints would be given, right?
Yes. Yes. Of course, there will be hints to find out the constant for integration.
Yeah, because if you can't find the constant, the
Then
equation is
it
kind of
remains same.
useless.
Yes. 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 Of course. Okay. So these are the procedure. Okay. So how can we find out the uh, position, velocity, and acceleration? Okay. Either uh, differentiate or integrate process. Okay. So these are the all about the lecture 1, week 2, and in next discussion class, I will discuss the motion in two-dimensional case. Okay. Okay. So do you have any question regarding this lecture or previous two lecture?
Sir, I have one question.
Yes, of course.
Sir, which book do you recommend for this course?
Already the book is given in private channel and also in Slack.
No,
The
sir.
name is Fundamental of Physics. Writer Resnick and Walker, 9th edition.
Okay, sir.
Yes. Yes. Uh,
Sir, in Slack I can find this, no?
yes, of course. In private channel and also in announcement, or just wait. The book PDF version is, yes. Oh, no. It's the recommended book given. So in private, if you add in the private channel
In
section,
Slack.
yes, in Slack section 11, then you can get the book, because I uploaded the book,
Okay, sir.
and also a file with name suggested point and problems.
Okay, thank you, sir.
Okay. Okay, so any more question?
No, sir.
Okay, if there is no question, then we can